Welcome to this tutorial on preprocessor scripting in Flexcom. My name is Angus Connolly and I'm the product manager for Flexcom software. So now I'm going to show you how you can use preprocessor scripting in Flexcom to generate a wide range of input files based on one master or generating your template input file at the beginning. I'm picking up from where I left off in the previous presentation, which I had run a single regular wave analysis of this riser system, this steep S system that we're looking at on the right hand side of the screen. So when you're doing riser design or analysis work, you won't just consider one single regular wave. In reality, you have lots and lots of different regular waves of different periods and different incident wave directions. You may even have different wave amplitudes. You may also adopt a random C approach where you might look at different combinations of HS and TZ or TP in a wave scatter diagram. So in summary, you can have hundreds and hundreds of different dynamic simulations. So here I'm going to show you how you actually go about creating those. In the model we're looking at on screen, I've got a single parameter for wave period, which has been predefined as 10 seconds. So that's hardwired as just one single value. So what I'm going to do now is I'm going to put in a variations keyword, which will allow me to just generate variations about this base value. So I can get the parameter I'm looking for is t, and I'm going to generate some values around that. So I'm going to generate let's say wave periods from 5 seconds up to, let's say, 25 seconds in steps of 1 second. So now what you'll notice is this is a template keyword file. Now it's not just a single wave period, it's many more of those. I'll just close this file just so we can refresh it. You notice on the file view on the right hand side now this dynamic it's put into italics. It's very subtle, but hopefully you can see it. That means it's a generating keyword file rather than just a single analysis. So that's vary the parameter. The rest of the parameters just stay the same. So the regular wave keyword has got a certain period. The time variables again relate back to period. We don't really need to worry about post-processing for the moment, so I'll just minimize those sections. What else do I need to do? As well as defining the variation of the parameter, I'll also need to, because I'm creating more files now, I need to kind of define what those files are called. So I'll proceed directly to this combinations keyword, which defines and controls what the file names are of the generated files. So I'll just call it description equals, let's say, waves. It doesn't really matter what I call this description name, it's just purely for descriptive purposes. Subdirectory will allow me to put it into some location, but what I'm really interested in here is the file name. So let me come up with some file name which will be representative of the wave period. So let me call it, let's say, wave, and now I'm going to use this % operator, which will refer back to the t, which is the period I've defined, and s just for seconds. So just bear with me one moment and let's see how this goes. So I'll just close this model view because it's not really helping us at the moment, and I'll just clean this directory completely so we can take out all of the old files so you can just see what's going on better. I'll delete all the files that are there, and I'll just show the input files, keyword files only. This is the handiest way. So when I run this analysis, it doesn't say run analysis. You notice it says generate variations, so it's not actually running a simulation, but it's making more input files. Switch on this status view as well so you can see that, and we'll wait just for a few moments for that to run. And you can see now that I have quite a lot of files in here. So where I just started with one file called dynamic, I now have all these other ones called wave, with a number, .key YXM. So if I just interrogate one of those, I'd open this wave 15 seconds. It's got this block at the top which says this is a manually or an automated file, not one that you manually create yourself, and you can see that it's set the parameter of t to be 15, whereas in the previous file here it was hardwired as just 10, but now I have generated lots and lots of variations. In this particular file, it's hardwired at 15 seconds. So the regular wave is 15-second period, the time variables again relate back to that 15-second period. So it's all fine. One problem or one minor detail here is that these files aren't listed in alphabetical order. So it kind of has 25 then 5. So let me just delete those ones for a moment, and I'll see if I can rectify that. Delete those. So what I can do is I can introduce another variable that is called t string, which is just a character expression of the same variable t being my wave parameter. So if I just use this format statement to format the period in the correct way that I want, I'll format the t, and I'm going to put it into this type of format, which is 2 digits, and then instead of referring to the wave parameter in the combinations keyword, I'm now referring to this wave period parameter, but just the character expression of it. So let me just run this again and see how we go. And we just wait for a moment until this runs. And so again, now they've been regenerated, but they're now in the correct format, so they're nicely in alphabetical order. So what if I wanted to kind of put that into, if I wanted to do something a little bit more complex? Let me just delete those ones. I could introduce another parameter called maybe direction, and I can maybe call that sort of 0 degrees, and I can create another character variation on that one. So this will be just called dir string, which is, the first one would be a number, like a real single precision number. This is a character expression, which is just a text version of it. So dir string is just to format the directory in, let's say three digits. So if I want to now put in a direction, let me go down to the regular wave period. So I've got an amplitude, let's say it's 5 meters. I've got a wave period, and now it's looking for a direction. So I need to refer to the direction which has been defined up at the top of the file. And then I also need to vary the direction. So let me just do that here. So I go para equals dir, and I'm going to look at different wave directions from, let's say, 0 degrees. I don't need to explicitly type in degrees here, but I just do it for clarity so you can see what the inputs mean. So I'm going to go from 0 degrees to, let's say, 330 degrees in 30 degree increments. So I'm going to create some regular waves now which come from incident wave directions right around the compass, and for each wave direction I'm going to look at a series of regular waves at different periods. So I just need to update my combinations keyword now, because I'm going to have a lot more keyword input files generated, so I need to put these in. Let's put them in a more ordered manner. So let's set these into a subdirectory called, just make up a thing here, I'll call it dir string subdirectory, and I just need to refer to, I use this % operator to refer to variables which are already defined in the preprocessor section. It's the only time you'll see this % operator used. It just tells Flexcom that you're referring to something that's a parameter which is also within this preprocessor section. This is all handled in the preprocessor section, and it's not related to data which happens beneath that in the load case section or any other subsequent sections. So let's me complete this keyword definition. I'll just hit the run button. This one will take a little bit longer to run because I'm creating more input files, but it should be pretty quick. So what you can see in the file view is that Flexcom is now creating all these different variations. So just to recap, what I'm doing here is I've defined a parameter for wave period and a different parameter for wave direction. I'm varying the wave period in steps of 1 second. So from my lowest wave period is 5 seconds up to a maximum of 25 seconds in 1 second intervals. And I'm doing a variation in directions from 0 degrees right around the compass, as I said, in 30 degree steps. For any one of these individual folders, if I open up this one here, this 120 degrees, you can see that the folder is named nicely and all of the files in there are named nicely. So for this particular input, I know that my wave period is 9 seconds and the wave direction is 120 degrees away from the global XY plane. So I have about over 10 different folders there, in each of which contain more than 10 different files. So I mean, you can build up hundreds and hundreds of simulations very, very quickly. So this shows you how the preprocessor scripting works within Flexcom itself. So define the parameters that you need at the top of the file, reference those parameters subsequently in the normal fashion, just substituting the parameter name for wherever it's required, rather than defining a numerical value hardwired. And so you use the parameters to define the parameters, you use this variation keyword to define how those parameters vary, and finally use this combinations keyword just to control what the file names are called in each, where they're located in terms of folders, and what the names of the actual files are within those folders. So that's how it's done for a regular wave case, which is very suitable for fixed increments. So it normally goes in 1 second or a half second increments up to from 5 up to 25 or 30 seconds. If you wanted to look at a random C simulation, which is normally characterized by way of scatter diagram, which is HS, significant wave height as a function of TZ, mean up crossing period, or TP, peak period, then we would need to adopt a slightly different approach, because these are not integer values. They're usually some values with some numerical precision. For example, they say 2.25 HS, 10.4 TZ or whatever. So I'll show you that in another tutorial in the next one. If you keep watching the series, the next tutorial will cover how you do pre-processor scripting for random C simulation. For now, we'll leave it at that, and I hope you can join me for the subsequent tutorials.